IV is a universal need and often requires dilution in order to meet the needs of all individuals. This is why we created a liquid IV dilution system that measures the temperature of the water, heats the water accordingly, and measures the amount of water combined with the IV. Join us as we walk you through the system.
Our system consists of an ultrasonic sensor, LED bulb, thermistor, handheld heater, water pump, force sensor, motor, and magnetic mixing mechanism.
So as you can see here, we have our predetermined liquid IV measured. We place our cup on our system and the LED light is signaled on. Now we are measuring the temperature of our water reservoir using a thermistor, as you can see there, and our handheld heater turns on or off according to the temperature that the water reservoir is at. Now I'm measuring how the thermistor works. So as you can see here, we're just going to do some unit testing where I'm measuring the temperature of my hand. You can see the rise in the graph there on the VI, and as I start to let go of the tip of the thermistor, you can see that the graph is starting to decrease as the temperature is scaling down to room temperature. Using an external power supply, as you can see there on the right, our heater is gaining additional current that will turn on and off depending on the thermistor settings. So right now we have it that if the temperature of the water reservoir is greater than 28 degrees, the heater turns off. But if it's less than 28 degrees, the heater will turn on and heat up the water that will then be pumped into our liquid IV. Once our water reservoir reaches the correct temperature, our mixing mechanism starts. So we will be dropping in this pill-like structure which has magnets on the bottom. The pump will initialize and the force sensor will stop the water once the initial amount of water is reached. So the force sensor is continuously recording the amount of water, and then once the level is reached, the mixing mechanism will start as the motor turns, which connects to a shaft, which then initializes the magnet movement and the rotation of the pill-like structure that we placed into the cup, which then mixes the liquid IV and the water simultaneously. So the following is a VI with graph representation for the thermistor, ultrasonic sensor, and heater. So as you can see here, there is a plotted difference in the temperature of the thermistor recordings. Now to measure the distance between the ultrasonic sensor and the bottom plate, we are using a Boolean light that will turn on only when the distance between the top plate and the bottom is less than 15. And as you can see there, the LED light will initialize. The following is the second half of the VI, which measures the temperature using a thermistor and plots it on the waveform chart, as you can see there on the right. Here we have our force sensor and pump VI in combination with the motor. Based on our VI, the force sensor is measuring from 0.02 to 0.06 sensitivity, and if the system has too much water, too little water, our pump will initialize using the case structure found below. The next VI controls the voltage going to the motor and controls the speed at which the shaft rotates.
Overall, our system is an innovative and efficient way to dilute liquid IV with minimal human contact due to automated processes, and can be adapted to varying forms of liquid medicine other than liquid IV.